Okay, so here's section 6.2, problem number 3. You got this graph for us. It has mean 100, standard deviation 15. So I always like to put the mean right in the middle, right? Because the mean means middle, average, right in the middle of the curve. They want me to find this x value here. Okay, well, we have two functions we use. Okay, and so to do this problem, what we want to do is we want to look at the exam 2 notes. Those are available. If you're in class, I've passed them out. If you're online, I've put a link at the Canvas course site. So here's exam 2 notes. It's not number 1 or number 2 or number 3. If you go to the second page, number 4, there it is. That's for normally distributed things where they give a mean and a standard deviation. First, draw the normal bell-shaped curve and put the line in the middle with the mean below it. So we did that. They've already given us the bell curve, and I just put the mean in there. Next, are they asking? They're either going to ask for a percentage. Skip this. This is later. This is actually some other section. This is, well, I won't worry. I won't bother you right now with it. So they're either asking for a percentage or they're giving us a percentage. Which one is it? Let's go back. They're asking for a percentage or they're giving a percentage. Well, here, this is it's a decimal, but it's the same thing as a percentage. It's a decimal version of a percentage. They're giving us a percent on this one. Okay, so what does that mean? If they give you a percent already, use an inverse norm. So I'm going to use inverse norm on the calculator, and it says area to the left, mean and standard. Area to the left, mean and standard. Okay. So, inverse norm. Now, what is the area to the left? Left of what? Well, left of this line, right? That's where x is. We're trying to find x. So if you want to find x, you got to find the area to the left of x. So what it means is this function, this inverse norm thing, is kind of like a vending machine. You give $1, it gives you back a soda. So in other words, it's saying you give me area to the left, you plug in right here, area to the left, and I'll give you back the x value, the spot. So in other words, if you want to know some spot on the bottom, x, some spot right there, you've got to give me area to the left of that spot, and I'll tell you that spot. Give me area to the left of that spot, and I'll tell you that spot. Well, how do we know area to the left? We know the area to the right, this is to the right, is 0.1026. So what is this area here? This is area to the left of x, right? This is all, the rest of the curve is the area to the left of this spot, right? How do you find the area to the left? They're telling me the area to the right is 0.1026. How do I find the area to the left? It's going to be 1 minus 0.1026, right? Because that's the rest of the curve. Just like if the chance of rain today is 20%, if that's the chance of rain, then the chance that it will not rain is 1 minus 0.20, in other words, 0.80. Right? There's a 20% chance it's going to rain. There's an 80% chance it's not going to rain. You take 1 minus the decimal and you get the rest of the percentage. Well, that's what we do with this curve. If the area to the right, if they're telling me right on the picture that the area to the right is 0.1026, and this inverse norm formula wants me to give area to the left, then the area to the left is 1 minus that. It's the rest of the area. 1 minus 0.1026. Then you put in the mean, that's 100. Standard deviation right there, 15. Type that into your calculator when you hit the buttons on the calculator, I'm doing it right now, it's going to be, it's the inverse norm. And literally just type in exactly this, 1 minus 0.1026. Don't even bother figuring out what that is ahead of time. The calculator can do it all. I'm getting 119, nearest whole number, 119.0, so just 119. This number must be 119. Makes sense, it's bigger than 100, huh? And the number's to the right of 100, so that IQ score must be 119.